All right, well, hey students, welcome back. Today, lecture is going to be focused on a different type of statistical analysis called a independent samples t-test. So we're going to be focusing on chapter 8 today. And if you remember last time we got together, we started to look at two different types of statistical analysis. One was a single sample t-test that was looking at one group of people and comparing it to the population, okay? Then we worked on the second type of t-test was called dependent means t-test, or in PSPP, we saw it as paired samples t-test. And that's when you had one group that was tested 2 times. So either tested before a workout or after a workout, or tested in 2 different interventions, but the person was tested twice, okay? So now today, what we're gonna be focusing on is what we're gonna call independent samples t-test. And this is the same type of t-test. So it looks just like this, independent samples t-test for chapter 8. The difference here with independent samples t-test is it's going to be comparing 2 samples, like an experimental group and a control group. What I mean by that is, in this case, you're comparing 2 separate independent groups. Okay, so think of it, you're comparing, say you're interested in total weight loss, but you want to compare how much weight loss did the men lose versus the women lose in the weight loss program. Okay, the groups are independent of each other. Okay, like I'm an independent person. You're not dependent in the relationship. You're an independent woman, right? So what that is saying is that you can't be involved in both groups. So if you're doing the weight loss program, you can't be male and female. It's one or the other. Another one would be, say you're doing there's a test that we're doing for depression, and we're interested, okay, does this depression drug, an SSRI, so a drug intervention, the study is interested, is this drug effective? So they have one group of people, we have 20 patients that take the new type of drug, okay? And then you have another 20 people who take the placebo, which is considered the control group. So you're comparing the placebo to the drug group. So the experimental group versus the control group. A patient, a participant in the study is not doing both. They can't do both at the same time. So if you're comparing 2 groups of people that are completely separate, that would do an independent samples t-test. Scores from the group are independent because they come from different groups. In your book, you're going to see diagrams like this. I want you to focus in on these top 2. These are 2 separate populations, okay? So if we're focusing on males and females, or we're interested in statistics students and art students, okay, and how much they study per week, okay? There's 2 separate populations that you're working with, okay? And then we have a distribution of means. This is taking the means of several means to get this distribution, and then kind of skip over here down to the sample. So as you trickle down, this population is for this sample, this population is for this sample here. So 2 separate samples for 2 separate populations that we're going to be working with, okay? So, and in regards to the distribution of means, as you look at the 5 steps, we're not going to have to focus in too much on that. But in your PowerPoint, you can kind of review some of that as well. So let's take a look at an example here of how you could do this in PSPP. Okay, so I have this open in our textbook here, and here's an example of an independent samples t-test. It says a researcher randomly assigns 5 individuals to an experimental procedure and 5 to a control condition. At the end of the study, all 10 are measured, and the scores for each experimental group are as follows. So it gives 5 scores, okay? 7, 6, 9, 7, and 5. And then the scores for the control group are 5, 2, 4, 3, and 6. It says carry out an independent means t-test at the 0.05 significance level, okay? So if I looked at step 1, we have 2 populations. So we're not, in these groups, we're not necessarily going to be saying the sample compared to the general population, because in this group, we don't know any, we're not talking about the general population, we're comparing one group to the other group. So POP1 is always the experimental group. So it's the people who received the experimental procedure, and population 2 is that those who did not. All right, we're just saying, is they're different? So the research hypothesis would be POP1 does not equal POP2, and then POP1 for the null hypothesis would be POP1 equals POP2. So if I go into my variable view, the way you're going to do this setup is a little bit different than the dependent means t-test, but not too tricky. So the first thing you're going to want to put in is you're going to have to decide, you're going to have two different variables. The first one is going to be the treatment, is whatever the two groups are, you need to give that a label. So I'll just say group. Okay, that's simple enough. And then the second thing you're going to do is your whatever you're measuring here. So it's the scores. I'm going to call it scores. Just push enter. So what the difference here is, what you're going to have to do is, what's very common is some people would say, okay, I'm going to have the experimental group, and then I'm going to list another variable for control group. And that's not the way you're going to set this up. So what you're going to have to do is just put a group label for this, and then you're going to go over to the values labels. Okay, when you click that, a box will populate, looks something like this. If it doesn't pop up for you right away, you just need to click off it and then click again, and it'll get you there. Okay, I know the program can be a little frustrating at times. So what you're going to do for this is you're going to label the values as 1s and 2s, depending on if it's an experimental or control group. So population 1 is, we're going to say, is the value for 1. Okay, because we can't write experimental group for everything. We need to give them labels as 1s and 2s. So I'm going to say experimental group. So you're going to give it a label, and then I'm going to click add, and it brings it down here. Then the second group that I'm working with, I'm going to label as a 2, and I'm going to call it a control group, and then click add. And that's all you're going to do, and you're going to click OK. And if you look down here now in the labels, it's going to give you 1s and 2s. This label you can add if you'd like. It just kind of gives you more information. So you can say group participants. I don't know if that's going to let me do that right. No. Group participants are in. This just allows you, because the names, you can only have a one word, you can have spaces. It allows you to give a label to it. All right. So now over here, I'm going to go over to data view, and I'm going to enter in my information. So it says there are 10 people measured. The experimental group had these values. So if I go back, my experimental group I labeled as 1. So I'm going to count how many 1s I have here. So I have 1, 2, 3, 4, 5. So I have 5 1s. 2. What I'm doing is telling the program that these next scores are all for the experimental group. And then I'm just going to give those numbers in. 7, 6, 9, 7, and 6. Okay. And so these are the experimental group, and they all are these numbers here. And then the next group of 5 numbers are the control group, which we labeled as 2s. 1, 2, 5. And then I'm just going to do those here. All right, so then I have my information here for my PSPP. And then in order to run I'm missing one here if you noticed. So my first 2 didn't come in. I got the 5. There we go. All right. In order to run my PSPP independent sample t-test, I'm going to go to Analyze, Compare Means, and then Independent Sample t-test. Analyze, Compare Means, Independent Sample t-test. I'm going to click, and it's going to bring me a box over here. And I have 2 types of boxes that I got to work with. Number 1 is the test variable. So this is always the dependent variable. Okay, so dependent variable you're going to bring over to the test variable. Let me click that over here. The grouping is how we group them. So in our case, we group them as 1s and 2s. So I'm going to bring these over to here, okay, down below. So Whatever ones you're comparing the two separate groups needs to make sure it's here. The next thing you're going to have to click here is you're going to have to go to define groups. Okay, it's going to pop open another box here. And this is key that you're going to have to do the drop down. And group one's value is at the experimental or the control group. Okay, we said that first one was, I believe, was the experimental group. So I'm going to define groups. Define groups, and that's the experimental group. And group two is the control group. Okay, I do the drop down. I don't want to type it in, need to use the drop down and then push continue. All right, and don't worry about options, and you're just going to push OK, and it's going to give you your output here. So let me just check, make sure that we got the right output for us. Perfect. All right, so let's kind of explore this a bit. So this one here is giving our information in regards to the two groups. So we have the experimental group, had a population, and the number of was 5, has a mean of 7, okay? So the average score of the 5 people was a 7, a standard deviation of 1.22. Control group was lower, mean of 4, and a 1.58, okay? Meaningful information you always want to know. The next thing you're gonna have two options here. It's two columns. So you're gonna assume variances, equal variance assumed for this case. So you use the top one here. The first, Levine's test of equality for variances, I don't want you to have to worry about that for right now. So what I want you to head over to is the T. The T is your T-score. Okay, this is very important for your statistic. You always want to report this. So we got a 3.35. Okay. My degrees of freedom, my DF, so n minus 1. So for this case, it's going to be for each group. So my DF is 8. Okay. And then right here is my significance value. Again, so it's 0.01. So in the question, it said it was less than, using the 0.05 significance level, do we reject or retain the null? So based on this information, we have a T of 3.35 and the significance of 0.01, which is less than what they said it needed to be, is 0.05. So since this number is less than 0.05, I reject the null. So I reject the null, which shows that the experimental group and the control group, there is a significant difference between the two groups. These two groups are not the same. So we can make the inference that the experiment, the intervention that was given had an impact. So there was a significant difference between these two groups. So that is kind of your output. Confidence intervals are over here. We're not going to focus on that for today. All right, let's look at one more practice problem today from our notes. So I'm going to go over to set 1, and I'm going to go to a little bit of a challenging one right here. It says this. It says an experimental psychologist was interested in whether using a student's own name in the story affected the child's attention span while reading. 6 children were randomly assigned to read a story under ordinary conditions using names like Dick and Jane. 5 others read versions of the same story, but their own child's name was substituted into the story. The research kept careful measure of how long it took each child to read the story. The results are shown in the following table. Using a 0.05 significance level, does including the child's name make a difference? Okay, so this is kind of maybe a little complicated. Number one, it's telling us there's 2 separate groups. One, 5 kids, or a separate one group has an ordinary story with the kids' names are just Dick and Jane. The next one is you're reading a story to a kid, but they actually use their own name. So does having their own name help impact how long the child will read the book? Okay, so that's the intervention that it's doing. So we have 2 separate groups, the ordinary story and then the own name story. So 2 separate groups. So again, independent samples t-test. And this is the labels A, B, C, D, E, and F. And these just kind of gives labels. It doesn't necessarily mean we need to label them ourselves like that. But then it's talking about the reading time. And then our independent variable is going to be our group. So I'm going to pull up my PSPP again. And I'm just going to go down here and I'm going to have, for this one, let's see. The first one, I'm going to have story. I can say story type, okay? Push enter, and I can give my label is ordinary story compared to own name story. Okay, and then I'm going to go again to the labels because I'm not going to give, I need to label them if they're ones and twos. So my first one is a 1, which is the ordinary story. So I'm going to call it the ordinary story, and then click add. And then 2, own name story, and click add. All right, so I have that one done. And now I'm comparing this, what I'm evaluating is my dependent variable is the reading time. Right, so then make sure it's all one word. So head over to here to my data view, and now I have how many ones do I have? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 5, 6. And then I have 1, 2, 3, 5 twos. 2. One thing I think is important for you to realize with these types of tests is you do not necessarily have to have equal groups. Okay. So let's go ahead and enter this information in. So we have 2, 5, 7, 9, 6, and 7. 2, 5, 7. Good. And then I'm going to go down to the next group right here, the 2s. So I have 4, 16, 11. Oops, typed in a 1. Always check yourself. 9. And the next thing here is it's not necessarily letting me go to the next one because I didn't have these ones go here. So I can just go back and I can clear these and it should take care of it for me. The reason this program is just a little bit picky. So in order to go back to the data view, now I should be able to go here and then add the last 2 that I needed. All right. So I have 4, 16, 11, 9, and 8. I have 1, 2, 3, 4, 5 2s, matches here, and I have 6 1s. All right. So we look good here, and now we're just going to run our analysis again. Go to Analyze, Compare Means, Independent Samples t-test. Bring that back over here. Got to reset it. So again, our test variable, what we're testing is the reading time. And then our grouping variable, the ones we put 1s and 2s in, you bring over to the bottom, and the grouping variable, go to Define Groups. And then you just need to make sure that you select the correct right ones for each group. And then push OK. And then it's gonna, you go down to the most recent output. And ordinary story, the mean is 6, standard deviation 2.37. Own story is 9.6 and 4.39 standard deviation. And I'm going to reading time, and I'm looking for my T is negative 1.74, degrees of freedom of 9, and my significance value is 0.116. To go back to my story, I'm looking at a level of 0.05. So 0.11 is more than 0.05. So what I do in this case is I retain my null hypothesis, meaning there is not a significant difference between the ordinary story and the own story. So there is not a significant difference between these two groups. So what I have to do is then retain my null hypothesis. All right, well, that about covers it for independent samples t-test. Should be able to get you going. Reach out with any questions, and look forward to talking soon.